Welcome to the Urban Herald. We're the team that digs into the big questions shaping, well, everything around us. For a good while now, the question's been, will AI change everything? But here in 2025, maybe the better question, the one we really need answers to, is how does this stuff actually work? I mean, think about it. Facial recognition unlocks your phone. Cars have self-driving features. Streaming services know what you want to watch next. It's everywhere. But how it all happens still feels a bit like, I don't know, digital magic to a lot of people. So our mission today from us here at the Urban Herald team is to pull back that curtain. We want to show you it's not sorcery. It's actually this, beautifully logical system. Math, data processing, finding patterns. It's all in there.
Exactly. And, to really get a handle on it, we first need to get our terms straight. It helps avoid confusion down the line. So at the very top, you've got artificial intelligence, AI. That's the big umbrella term, right?
Right.
It covers any system that can do tasks we normally think need human intelligence.
Yeah.
Problem solving, making decisions, understanding language, things like that.
Okay, the big picture. AI is the umbrella. So what's under it?
We'll zoom in a bit, and you get machine learning, or ML. Now, this is a specific way of doing AI. It's about computers learning from data to make predictions or decisions without someone programming every single step explicitly. They learn patterns from examples, and then go one level deeper, and you hit deep learning, DL. That's a subset of machine learning that uses these things called neural networks, especially ones with lots of layers, to tackle really complex information.
Ah, okay, so layers. Like if AI is the whole city, say London, machine learning is maybe a borough, like Westminster, and deep learning is like a specific, very advanced neighborhood inside Westminster.
That's a great analogy. Yeah, precisely. And it really highlights that we're not just talking about simple rule-based systems anymore. These modern AI systems, they adapt, they improve over time, and honestly, sometimes they come up with solutions that genuinely surprise us. And understanding these differences, AI versus ML versus DL, it isn't just for tech folks. It's becoming fundamental, Yeah. to understand the tools changing how we work and live.
Right. So with those terms clearer, let's actually dive in. How do these systems learn? You mentioned three core approaches to machine learning.
That's right. These are sort of the foundational methods. Get these, and the rest starts to make more sense.
Okay, first up is supervised learning. What's the deal there?
Okay, supervised learning is like having a really patient teacher. You feed the AI algorithm tons of examples that are already labeled with the correct answer. Think thousands of pictures labeled cat or not cat, or emails marked spam or not spam. The algorithm learns the patterns that connect the input data to the correct label, so it can then classify new unseen data. It's used everywhere: medical diagnosis, spam filters, spotting fraud.
Got it. Learning from labeled examples? What about the opposite?
Well, that leads us to unsupervised learning. This is more like exploration. No labels, no teacher telling it the answers. The algorithm just gets raw data, and its job is to find hidden structures or patterns within that data. Maybe it finds natural groupings of customers in marketing data that humans didn't see, or it spots weird, anomalous behavior on a computer network that could signal an attack. It's about discovering structure in the unknown.
Okay, so finding hidden patterns. And the third type, you said it was maybe the most dynamic.
Ah, yes, reinforcement learning. This one is fascinating. It's about learning through trial and error. You put an AI agent in an environment, and it learns by taking actions and getting rewards or penalties based on the outcomes. It's trying to figure out the best sequence of actions over time to maximize its total reward. Not just the immediate win, but the long-term goal. This is how AI learned to beat world champions at chess and Go, and it's absolutely crucial for things like self-driving cars, learning how to navigate a complex, changing world.
That trial and error approach,
Yeah.
that seems incredibly powerful.
It is. And underpinning many of these learning approaches, especially deep learning, is the concept of the neural network. Now, these are inspired by the brain, but really, they're sophisticated mathematical functions. Think of them as layers of interconnected nodes, kind of like neurons. You have an input layer getting the raw data, then one or more hidden layers doing the processing, and finally an output layer giving the result. And the key thing is, each connection between these nodes has a weight, a number that determines how much influence one node has on the next.
And you mentioned they learn hierarchical representations. What does that mean in practice?
Yeah, so imagine feeding it an image. The first layer might just detect simple things, like edges or corners. The next layer combines those edges to recognize basic shapes. Then deeper layers combine shapes to identify objects, like a face or a car. It builds up understanding level by level, from simple features to complex concepts. It's pretty elegant, actually.
Okay, so we have the structure, the neural network. But how does it go from being, like, clueless to actually making accurate predictions, the learning part?
Right? The training process. This is where the magic, or rather the math, happens. It starts with all those connection weights set randomly. Basically, it knows nothing. Then you show it data, it makes a guess, and you compare its guess to the correct answer. There's usually an error, right? And through a really clever algorithm called backpropagation, the system figures out how much each weight contributed to that error. It then adjusts those weights, just slightly, to reduce the error next time. Repeat this millions, even billions of times.
Yeah.
And it gets good, really good.
And that whole process hinges on having data, right? Lots of it.
Absolutely critical. You often hear data scientists say that data collection and cleaning, pre-processing, takes up maybe 80% of their time.
Okay.
And there's a reason for that. The quality of your AI is directly tied to the quality of your data. Garbage in, garbage out, as they say. So this iterative cycle, predict, check error, adjust weights, repeat, powered by massive amounts of good data. That's how these systems learn.
Okay, so we've covered the learning approaches, the neural network structure, the training. Let's talk about some specific algorithms that are really driving things today.
Good idea. There are a few key ones worth knowing.
Let's start with vision. What's making AI so good at seeing?
That would largely be convolutional neural networks, or CNNs. These are the workhorses for anything involving computer vision, especially images. They're designed specifically for grid-like data. Their trick is using these things called filters, or kernels. Think of them as small windows that slide across the image, looking for specific features, edges, textures, patterns, you name it.
So they kind of scan the image.
Yeah, almost like how our eyes might scan a scene, picking out important details. It's very effective. CNNs power facial recognition, obviously, but also medical image analysis, detecting cancer, for instance, sometimes with superhuman accuracy, and object recognition in autonomous vehicles.
Okay, CNNs for vision. What about language? AI seems to have gotten incredibly good at understanding and generating text recently.
Yes. That's largely down to the transformer architecture. This really changed the game for natural language processing, or NLP. Before transformers, models process text mostly word by word, sequentially, which makes it hard to grasp long-range context. Transformers, though, can look at whole sentences or even paragraphs at once. They use something called an attention mechanism.
Attention mechanism.
Yeah, it lets the model weigh the importance of different words when processing any given word. It can pay more attention to relevant words, even if they're far apart in the sentence. This gives it a much deeper understanding of context and relationships. It's the engine behind models like ChatGPT, enabling amazing things like translation, summarization, writing assistance, even code generation.
Incredible. And what about decision making? You mentioned reinforcement learning earlier. Are there specific algorithms there?
Definitely. Key algorithms in reinforcement learning include things like Q-learning, and especially when combined with neural networks, deep Q networks, DQNs. These are more sophisticated because they learn to make decisions based on long-term consequences, not just immediate rewards. They think ahead, so to speak. They're crucial for teaching AI to play complex strategy games, but also for real-world tasks like managing investment portfolios or controlling robotic systems and autonomous vehicles where sequences of decisions matter.
Okay, so these algorithms are powering AI everywhere. Let's maybe look at some specific applications in, say, 2025. Where is this stuff really making an impact?
Oh, it's quite mind-boggling when you step back. Take healthcare. AI, particularly using those CNNs, is becoming incredibly good at diagnosing diseases from medical images. Things like diabetic retinopathy from eye scans, spotting skin cancer from photos, identifying pneumonia in chest x-rays, often matching or even beating expert human radiologists. Plus, AI doesn't get tired. It's available 24/7, and it can help bring expertise to remote areas. Yeah, it's a huge potential benefit.
And language, you mentioned NLP.
Right. Natural language processing is way beyond basic chatbots now. Thanks to transformers, AI can translate hundreds of languages fluently. It can summarize long documents accurately, generate creative text formats, write marketing copy, even write functional software code. It's changing how we interact with information and create content.
And computer vision. It
Oh,
seems
yeah.
like it's just everywhere.
It really is. Autonomous vehicles use it to navigate traffic and pedestrians. Security systems use it for identifying people or detecting intrusions. In manufacturing, it's used for quality control, spotting tiny defects. In agriculture, drones use computer vision to monitor crop health. It's often working quietly in the background, but it's embedded in so many systems now.
It sounds amazing, but we at the Urban Herald always try to look at the full picture. It can't all be smooth sailing, right? What are the big hurdles?
No, absolutely not. There are significant technical challenges, and it's crucial we talk about them. First, there's the data quality dilemma. We talked about needing lots of data. Well, real-world data is almost always messy. You get missing values, inconsistent formats, errors, duplicates, and bias. We'll come back to bias. So a huge amount of effort goes into data pre-processing, cleaning it, fixing errors, handling missing bits, making sure it's usable. It's tedious, but utterly essential. Remember, garbage in, garbage out.
Right. And you mentioned bias. That sounds like a big one.
It's a huge one. The bias problem. AI systems learn from the data they're trained on. If that data reflects historical biases, say, biased hiring practices in the past, the AI can learn and even amplify those biases. So an AI recruitment tool trained on biased data might unfairly screen out perfectly qualified candidates from certain groups. It's a serious risk. Fighting this requires really careful data collection, designing algorithms to be fair, and constantly monitoring AI systems after they're deployed.
So data quality, bias,
hmm
anything else major?
Oh, yeah. The sheer computational requirements. Training these state-of-the-art AI models, especially the big language models or complex vision systems, takes massive amounts of computing power. We're talking hundreds, sometimes thousands, of specialized processors, GPUs, running for weeks or months straight. This costs a fortune, uses enormous amounts of energy, and raises environmental concerns. So there's a big push for more efficient AI methods and hardware.
Okay, challenges noted. What about the future then? Where is all this heading?
Well, looking ahead, there's some really fascinating directions.
Such as?
One big area is multimodal AI. These are systems designed to understand and process information from multiple types of data at once. Text, images, audio, video, maybe even sensor data. Instead of just understanding text or images, they can find connections between them. Imagine an AI that reads a news article, looks at the related photos, listens to an audio clip, and synthesizes a much richer understanding than any single mode could provide.
Wow, okay. Processing everything together. What else?
Then there's the rise of agentic AI. We're moving towards AI systems that don't just provide information or generate content, but can actually take actions in the world on our behalf. Think of an AI assistant that you can ask to book me a flight to London next Tuesday. And it actually goes through the booking process, handles payments, maybe even checks you in. Or managing complex workflows in a business without constant human hand-holding. They become proactive agents, not just passive tools.
Autonomous agents.
Yeah.
Okay. And how does AI fit with other tech trends?
We're seeing increasing integration with other technologies. AI combined with edge computing, putting AI processing directly on devices instead of the cloud. AI combined with the Internet of Things, IoT, so smart devices become truly intelligent. Even AI combined with blockchain for secure data handling. This points towards distributed intelligence. AI won't just be in data centers. It'll be embedded everywhere, your phone, car, appliances, maybe even your clothes, creating a sort of ambient intelligence.
That's quite a future unfolding. But amidst all this powerful tech, what about the human element? Where do we fit in?
That's perhaps the most crucial point. Despite everything AI can do, human insight, creativity, and ethical judgment remain absolutely essential. AI is fantastic at finding patterns in data, at optimizing complex systems. But it doesn't truly understand context the way we do. It doesn't have common sense or ethical reasoning or genuine creativity. The real power comes when AI augments human intelligence, taking over repetitive tasks, finding insights we might miss, freeing us up for higher-level thinking and decision-making. It complements us. It doesn't replace us.
I like that framing augmentation. But do you worry people might hear augmentation and still think it's just a step towards eventual replacement, especially with those agentic AIs you mentioned? How do we keep that distinction clear?
That's a really important point to stress. The key distinction often lies in, well, agency and intent. Current AI executes tasks based on the objectives we set and the data we provide. Humans provide the purpose, the ethical framework, the why. And this is why understanding how AI works isn't just for tech geeks anymore. It's becoming fundamental digital literacy. Think about it. AI is increasingly used in hiring, loan applications, medical diagnostics, even the justice system. As citizens, as individuals, you need the ability to ask informed questions. How does the system work? What data was it trained on? Is it fair? Is it being used responsibly? Your ability to ask those questions is becoming vital.
Absolutely. So wrapping up our deep dive today from the Urban Herald team, the big takeaway seems to be that AI isn't one single thing. It's this whole ecosystem, right? Different algorithms, different structures, different approaches like supervised, unsupervised, reinforcement learning, all tackling different problems.
Precisely.
Yeah.
And what's truly remarkable about where we are in 2025 is that this represents a fundamental shift. We're not just building tools anymore. We're building systems that learn, that adapt, that sometimes genuinely surprise us. They enhance our own abilities in ways that honestly felt like science fiction not that long ago.
Mm.
The real magic, if you want to call it that, isn't in one specific algorithm. It's in this powerful combination. Massive amounts of data, incredible computing power, and really clever mathematics and statistics. That combination lets machines find patterns and make decisions that complement what we humans do best. Getting a grasp of these fundamentals, I think that's one of the most valuable investments anyone can make in understanding the future that's unfolding right now.
A perfect place to leave it. Thank you for joining this deep dive into the mechanics of modern AI with the Urban Herald team. We hope it sparked some curiosity. Keep exploring, keep questioning, because understanding this technology truly is key to navigating the world ahead.